Hey guys, in this video today we're going to learn about binary search trees, specifically how to create a binary search tree, how to insert nodes into a binary search tree. I expect that you know a little bit about binary search trees. If you don't, I recommend Geeks for Geeks. Just Google binary search tree. It'll explain some of the basics. Give it a couple minutes, 2 minutes, you'll be caught up. It's not that complicated. Another site that's really good, this is by the University of San Francisco. And this is a pretty cool illustration. Probably your professor's already told you about it, but you can put in a number here, hit enter for insert, and it'll show you the operations that should happen for a binary search tree. So that's pretty cool. And you can go back and you can delete and find, and it'll print. It'll go through everything for you if you want. So it's like an in order traversal here, which is kind of cool. So I highly recommend this site. It's definitely useful if you get confused on what's going on. Let's go ahead and move back to our code now. So here I've got my number tree, and I'm calling insert node on, and I'm just calling on the members of this array. Of course, this could be information we read in from a file just as easily. All we'd have to do is change the variable and figure out how we wanted to call this insert node. It could also be user-defined input. Wouldn't be that hard to change it. And then in our mytree.h, so we'll start here with our structs. So of course the class is going to provide the basic structure, and then our leaves are going to be stored in each one of the nodes. So I've just called my struct leaf. So we've got a bunch of leaves. Here only thing we're saving here is a number, some integer, and then we've got our leaf parent, our leaf left child, and leaf right child. And then we've got our default constructor, and then I've overloaded it, and it's expecting an integer in this case. And all this does is it sets our num value here, our integer num value, equal to whatever we pass into it. So that's all that happens there. And then it goes ahead and assigns parent, left child, and right child all equal to null. And the reason we want to do that is because if we just declare this variable, it's possible that there's information still stored there, and so if we try and access it, it might throw some weird error or let us do it even though it should be initiated to null. So we just went ahead and initiated it to null. Looking down here, we've got a couple of functions that are commented out. Don't worry about those. We'll probably deal with those in future videos. Main thing we're going to work on today is this insert node here, and we can see that it's expecting some integer value. We'll do our print nodes in our next video. Down here in private, you can see that we have our root, so our leaf, that's our root, and we're going to go ahead and initiate that to null whenever we instantiate a member of this class myTree. And again, same reason we're starting that with null. So moving over, we've got our insert node function here. That's what we're going to be working on for the rest of the video. And just ignore this part for right now. Let's look right up here at the top. So we've got three things that we're initiating, 3 pointers that are of our leaf type. We've got our new leaf, and we're going to go ahead and call the constructor, call new, and then call the constructor, and we're going to pass in the integer that we want to set our new leaf, store in our new leaf rather. And then we have 2 other leaves, so we've got our iterator, and we're going to start that at the root, and then we have our iterator parent, and since we're starting with the root, we're just going to go ahead and set that to null. Now we've got this if statement here. If our root equals null, that means that we haven't started, our tree is empty. We don't have a tree. It's a leafless tree. We're going to go ahead and set our root equal to our new leaf. So we'll go ahead and start our tree there. And when I chose these numbers here, these are all numbers between 1 and 100, and I went ahead and put 50 first, so that would be our root in this case. There's a lot of different things you could do. Remember that if this is in a different order but all the same numbers, you could still come up with a different tree. So assuming that's not the case, assuming that we've already initiated our tree and that 50 is our root, then we're going to go ahead and enter this else statement. And then what we're doing here with this while operator, we've got this while loop, you can see it starts there and ends here, is we're just trying to get down to the end of our tree. So to go back here and look at this, basically what we're going to do is we're going to get some number that we want to insert into our tree. And what we want to do is, depending on what that number is either go right if it's larger than 50 or left if it's less than. And then we're eventually going to get down here and remember that there's a couple of null. This has a null left child and null right child. And that's the case we're trying to get to. So we're just trying to traverse this tree until we get to the right location and we end up at a null node. So that's all this while loop is doing. And the way it does it is, the first thing it does when we enter the while loop, so the iterator does not equal null. So now we're going to set the iterator parent equal to the iterator, and then we've got this if-else statement where we're actually moving our iterator down. So if the value stored at our iterator is greater than or equal to the value stored in our new leaf, then we want to go to the left child, right? So it means that the value we want to store is less than wherever we're at. So in this case, we're at 50. It means the value is less than 50. So we would move down the left side of the tree here. And if that is not the case, then we move into the else part, and the iterator is now, we know that the iterator is less than the value stored at our new leaf, so we don't need an if there. So we'll just say our iterator is now equal to iterator right child. And all that would do is move us down the right side of the tree. And so what we're going to do, let's say we had a number, let's do 62. And I'll just go ahead and insert it, and we'll see what happens. So it's greater than 50, moves down, it's less than 75, greater than 54, less than 75, less than 79, and eventually it gets this null node, and that's where we're at in our code. And of course it went ahead and inserted it for us, but that's where we're at here. We're at a null node, and now if you'll remember that we had this iterator parent was equal to what our iterator was last. So in this situation, we moved our iterator to here, and it's null, and then the iterator parent is here. It says 69. Sorry to keep going back and forth. I hope that's not confusing. So now we're going to go ahead and go into the if statement, and we're saying, okay, if iterator parent, the value stored there is greater than or equal to the value stored in our new leaf, then we want our iterator parent left child to equal our new leaf. So it goes from null to equal our new leaf. And then our new leaf parent is going to equal our iterator parent. Now if it's a case that our iterator parent is less than the value stored, the value stored at iterator parent is less than the value stored in our new leaf, then we're going to go into this else statement here, and our iterator parent right child is now going to equal new leaf. And remember that the iterator parent had null values for where we were at. And remember the iterator parent originally had null values there. And then our new leaf parent is going to equal our iterator parent. And that's it for inserting into a node. So there's really nothing else to it. Of course, depending on what you read in, you could end up with some kind of weird trees like what I have here. So that's important to keep in mind. So that's it. That's all there is to it. And we'll go ahead and go back into main. I'm going to uncomment out this print statement. We'll look at this print statement more in our next video, but this is an in order traversal. So what we should expect is that this should print out this list of numbers, but all in order. And yeah, it looks like it's working okay. We definitely created a tree here, and we're able to print it out. So that's it for now. We'll see you in the next video.